So on April 6, 2026, four astronauts aboard NASA's Orion spacecraft swung behind the far side of the moon and disappeared. For 40 minutes, no signal could reach them, no voice from mission control, no telemetry, no data link of any kind. The moon itself, 2,160 miles of solid rock, stood between them and every other human being alive. They were the foremost isolated people in the history of our species, farther from home than any human has ever traveled, 252,760 miles from Earth, inside a capsule roughly the size of an SUV, completely alone. And during those 40 minutes, they saw something that 31 cameras aboard the spacecraft could not capture. Bright, sudden flashes of light erupting across the darkened lunar surface. Millisecond bursts appearing at random locations on the far side of the moon. The hemisphere that no human being has ever monitored from this close, visible to the naked eye but nearly impossible for any camera to record. 6 confirmed impacts were documented during the broader 7-hour flyby observation period. Meteoroids slamming into the moon at tens of kilometers per second, releasing enough energy to produce visible flashes from more than 4,000 miles away. And when the crew reported what they had seen after communication was restored, something unusual happened at mission control. NASA officials later confessed that the astronauts' descriptions did not match what the team on the ground was observing in the camera feeds. The cameras saw the lunar surface. The cameras saw craters and shadows and geological features in extraordinary detail. But the cameras did not see the flashes. The human eye did. Not instrument artifacts. Not reflections off the spacecraft windows. Not cosmic ray hits on the camera sensors, or digital noise, or any kind of processing error. Real, physical, violent events happening on the surface of the moon, witnessed by 4 human beings who were the only people in the history of our species to ever be in a position to see them. Because from Earth, the far side of the moon is permanently hidden. It always faces away from us, locked in synchronous rotation, showing the same face to Earth for as long as the moon has existed. No ground-based telescope has ever observed its surface directly, and no camera in lunar orbit has ever been designed to catch millisecond duration random impacts across its full disk. It took human eyes, in the right place, at the right time, looking in the right direction, to finally see what has been happening on the other side of the moon for 4.5 billion years. The scientists who analyzed the observations were not calling them a curiosity. They were calling them a validation of why you send human beings to the moon instead of robots. Because a robot would have missed this entirely. A robot does not glance to the side. A robot does not notice a flash at the edge of its peripheral vision and react in real time. A robot photographs what it is pointed at. A human being sees what is happening. And what was happening on the far side of the moon on April 6, 2026, was something no robot had ever detected and no human had ever witnessed. And here is the part that made the hair stand up on the back of every lunar scientist's neck. Because the Artemis II crew was not the first to report seeing flashes on the moon. 54 years ago, in December 1972, Apollo 17 astronaut Harrison Schmitt reported mysterious flashes during lunar night. He saw them, he reported them, but nobody could confirm what he saw. The cameras of 1972 were not capable of recording millisecond transient events at random positions on an unlit surface. The data to verify his report simply did not exist. For 54 years, Schmitt's observations sat in the Apollo archives, unconfirmed, unexplained, somewhere between scientific anecdote and astronaut legend. On April 6, 2026, the Artemis II crew confirmed them. What Schmitt saw in 1972 was real. It was always real. And the moon has been under continuous bombardment the entire time. We just never sent anyone back to watch. And this matters beyond science, because NASA is planning to build a permanent base near the moon's south pole, the Artemis Base Camp. If meteoroid impacts are striking the lunar surface with enough energy to produce visible flashes from 4,000 miles away, those impacts represent a direct hazard to any structure, any habitat, any human being working on that surface. What the crew accidentally witnessed during a 40-minute communication blackout is now driving safety calculations for every future lunar mission. Impact frequency, size distribution, energy profiles, shielding requirements. These are no longer theoretical inputs to a model. They are observed data from the only 4 people who have ever watched the far side of the moon being hit. Stay with me, because by the time this is over, you will understand why the most significant observations from the first crewed lunar mission in 54 years were not the photographs. They were not the data. They were not the measurements or the telemetry or the solar eclipse imagery. They were what 4 human beings saw with their own eyes, behind the moon, alone, cut off from Earth, that no camera could record, and why that changes the argument about whether humans belong in space. I am Graham Prescott, and if stories like this are what you come here for, subscribe right now because we are just getting started. December 1972, Apollo 17 splashes down in the Pacific Ocean. Gene Cernan, the last man to walk on the moon, climbs out of the capsule and into a recovery raft. Behind him, the lunar program ends. The hardware is mothballed. The budgets are redirected. The astronaut corps shrinks. And for 54 years, nobody goes back. Not because we could not. Not because the technology was lost, although much of it was. Not because the science was complete, because it was nowhere close to complete. We stopped going because the political will evaporated. The funding dried up, and the public moved on to other things. For 54 years, the moon hung in the sky, 240,000 miles away, visited only by robotic probes and orbital cameras, and the occasional intentional crash of a spent rocket stage. Then, on April 1, 2026, at 6:35 p.m. Eastern Daylight Time, a Space Launch System rocket lifted off from Launch Complex 39B at Kennedy Space Center, carrying 4 astronauts in an Orion capsule they had named Integrity. Commander Reed Wiseman, pilot Victor Glover, who would become the first person of color to travel beyond low Earth orbit, mission specialist Christina Koch, who would become the first woman to travel beyond low Earth orbit, and mission specialist Jeremy Hansen of the Canadian Space Agency, who would become the first non-American citizen to leave the vicinity of Earth. 4 people in a capsule roughly the size of an SUV, sitting on top of the most powerful rocket NASA has ever flown, heading for a place no human being had visited in more than half a century. The journey to the moon took 5 days. 5 days of coasting through the void between Earth and its only natural satellite, watching the Earth shrink in the windows and the moon grow. On the evening of April 2nd, the translunar injection burn fired for 15 seconds at 7:49 p.m. EDT, pushing Orion out of Earth orbit and onto a trajectory aimed at the moon. Christina Koch described the transition in words that captured what it feels like to leave the safety of Earth's gravitational embrace. "We are now falling to the moon rather than rising away from Earth," she said. "It is an amazing milestone." Before the flyby began, the crew received a special recorded message from Jim Lovell, the Apollo 8 and Apollo 13 astronaut who was among the first humans to see the far side of the moon in person. Lovell had recorded the message before his passing in 2025. His voice, reaching forward from the generation that first went to the moon, speaking to the generation that was going back, carried a weight that everyone in the control room felt. On April 6th, 5 days after launch, the crew reached the moon. And what happened during the next 7 hours is why this mission will be studied for decades. Let me walk you through exactly what happened on April 6th, because the sequence matters, and the details are what elevate this from a headline to a story that belongs in the permanent record of human exploration. Orion entered the moon's sphere of influence at 12:37 a.m. EDT, the point at which the moon's gravity pulled harder on the spacecraft than Earth's did. From that moment, they were falling toward the moon. Throughout the morning, the moon grew in the windows until it filled the frame entirely, a wall of gray and white craters stretching from edge to edge of every viewport. At 1:56 p.m. EDT, the spacecraft broke the record for the farthest distance any human being has ever traveled from Earth, 252,760 miles. The previous record, set by Apollo 13 in April 1970 during its emergency free return trajectory, was 248,655 miles. That record had stood for 56 years. It fell on a Monday afternoon, while 4 astronauts watched the cratered surface of the moon scroll beneath them. Then the communication blackout began. As Orion swung around the far side, the moon itself blocked all radio signals between the spacecraft and Earth. No voice could reach them. No command could be sent. No telemetry could be received. No emergency abort signal could get through. For approximately 40 minutes, the crew of Artemis II was completely, utterly, physically alone, in a way that almost no human being has ever experienced. Cut off from mission control, cut off from their families, cut off from the entire population of Earth by 2,160 miles of solid lunar rock. The last humans to experience this blackout were the Apollo crews, and even they had the comfort of knowing that ground controllers were listening for their signal to reappear on the other side. The Artemis II crew had that same comfort, but nothing about it was comfortable. Koch later described the moment to President Trump in a phone call after communications were restored. "I said a little prayer," she told him, "and in that prayer was everything that the moment contained. The isolation, unlike anything you can experience on Earth, where even the most remote places still have sky above them and ground below them, and the knowledge that other humans exist somewhere over the horizon. The vulnerability, because if something went wrong behind the moon, no help could arrive, no guidance could be sent, no voice could say what to do. And the awe, because outside the windows was a surface that no living thing had watched from this distance since the Apollo missions, and before that, not ever. Not once in the 4.5 billion years the moon has existed. They had 31 cameras, 15 fixed to the spacecraft in various positions, recording continuously in some cases, 17 handheld by the crew members themselves, including Nikon Z9 bodies equipped with professional-grade optics, some of the finest camera hardware ever carried beyond low Earth orbit. The crew had been trained in photography. They had rehearsed observation protocols. They knew exactly what they were supposed to photograph and when. And what they saw during those 40 minutes, what they witnessed on the dark surface of the far side, the cameras could not capture. The impact flashes came without warning. Brief, brilliant, millisecond-long bursts of light appearing at random locations across the darkened far side of the moon. A flash here, silence. Another flash there, in a completely different location. Gone before you could point a camera at it. Gone before your finger could find the shutter button. The flashes were caused by meteoroids, tiny fragments of rock and metal traveling through space at enormous speeds, slamming into the lunar surface with enough kinetic energy to vaporize themselves, and a portion of the regolith on impact, producing a brief, brilliant flash of light visible from thousands of miles away. Imagine trying to photograph a single firefly in a dark field the size of a football stadium, using a telephoto lens. You know it is out there. You can see it flash with your naked eye. But by the time you swing the camera toward it, it is already gone. Now imagine the field is the size of the moon's entire far side, and the firefly's flash lasts 1,000th of a second. That is why the cameras missed them. The cameras were set to specific exposures, specific focal lengths, specific frame rates optimized for high-resolution surface photography. They were not configured to detect random millisecond transient events at unpredictable locations across a dark hemisphere. The human eye, with its wide field of view, its ability to detect sudden brightness changes against dark backgrounds, and its capacity to react in real time, saw what the cameras could not. 6 confirmed impacts were documented across the broader observation period. About 24 scientists had packed into a conference room adjacent to Mission Control at Johnson Space Center in Houston, specifically to record the crew's real-time verbal descriptions of the phenomena as they watched. The scientists knew the cameras would probably miss the flashes. They were counting on the astronauts' eyes. And the astronauts delivered. When the crew described what they were seeing, their reports were vivid, immediate, and precise. But when Mission Control checked the camera feeds, the flashes were not there. The debrief reported it directly. Some of their observations were so impressive that NASA officials have confessed the astronauts' descriptions initially didn't seem to match what the team back at Mission Control was observing. The cameras saw the surface. The crew saw events on the surface. That distinction is the reason human spaceflight exists. Now, let me explain why this matters beyond the moon, because the implications of what the crew saw extend far beyond a few flashes of light. This is the argument for human spaceflight distilled to its absolute essence. A robotic orbiter can photograph the lunar surface in extraordinary resolution. A robotic lander can analyze soil composition with precision no human hand can match. A robotic rover can traverse terrain that would be dangerous for a suited astronaut. Robots are better at sustained, repetitive, precise measurement. They do not get tired. They do not need food or oxygen or sleep. They do not say little prayers when the communication link goes dark. But robots cannot notice the unexpected. They photograph what they are pointed at. They measure what they are programmed to measure. They do not glance to the side and catch something at the edge of their peripheral vision. They do not react in real time to an event that lasts 1,000th of a second and happens at a location nobody predicted. A human being does. And on April 6, 2026, that capability produced the first direct human observation of meteoroid impacts on the far side of the moon in the history of our species. The cameras had 31 chances. The human eye had 4. And the human eye won. But the impact flashes were not the only extraordinary thing the crew witnessed during the flyby. Because what they saw when the moon passed between their spacecraft and the sun had never been seen by human eyes from this distance. Not once. Not ever. As Orion continued its trajectory behind the moon eclipsed the sun, a total solar eclipse, viewed not from the surface of Earth through a narrow band of totality, but from the vicinity of the moon itself, lasting nearly 53 minutes. From the surface of the Earth, The longest possible total solar eclipse lasts approximately 7 minutes and 28 seconds. The geometry is fleeting, the shadow narrow, the experience over almost before it begins. The Artemis II crew experienced an eclipse nearly 8 times longer than anything any human being has ever witnessed from any location. For almost an hour, the sun disappeared behind the dark disk of the moon, and the solar corona, the outer atmosphere of the sun that is normally invisible because it is overwhelmed by the sun's direct brightness, blazed into view. A luminous halo of superheated plasma surrounding the lunar silhouette, streamers and loops and filaments of ionized gas extending millions of miles into space, visible in detail that ground-based eclipse observers can only dream of achieving through the distortion of Earth's atmosphere. Stars appeared in the background that are normally far too faint to image when the moon is in the frame, but with the moon blocking the sun and its own surface mostly dark, the stellar background emerged. Saturn was visible as a distinct point of light just below the moon's lower right edge. Mars was visible at the right edge of the frame. The faint glow of Earthshine, sunlight reflected off the cloud-covered surface of Earth bouncing back to illuminate the near side of the moon, was visible as a soft luminescence against the otherwise dark lunar disk, giving the moon a ghostly presence even in full eclipse. Scientists have already published a peer-reviewed paper on the RxIV preprint server, analyzing the morphology of the solar corona's F component from the Artemis II eclipse image, using a single 2-second exposure taken with a Nikon Z9 camera at ISO 1600 and a 35mm lens at f2. A single photograph, taken by an astronaut from a capsule behind the moon, is already generating astrophysical research that could not have been conducted from any other vantage point. And then the crew witnessed something no human being has ever seen before. As Orion continued around the far side, Earth sank below the lunar horizon. Earth set. Not a sunset, an Earth set. The planet they came from, the only home any human being has ever known, every person they have ever loved, every place they have ever lived, every memory they have ever formed, dropping below a cratered lunar horizon and disappearing from view entirely. For a period of time, there was no Earth visible from their windows, just the moon below and the stars above, and the absolute, complete, total isolation of being on the wrong side of the moon. NASA released the image and named it EarthSat, a deliberate callback to the iconic Earthrise photograph taken by Apollo 8 astronaut Bill Anders in December 1968, the image that showed humanity its own fragility for the first time. The White House shared the new image with a caption that captured its weight. Humanity, from the other side. First photo from the far side of the moon, captured from Orion as Earth dips beyond the lunar horizon. A crescent Earth, swirling white clouds over the Oceania region, the dark night side visible, dropping behind a surface pocked with ancient craters that have not changed in billions of years. Then, as Orion continued its trajectory and emerged from behind the moon, Earth rose again. The crew watched their planet disappear, and they watched it come back, and in between, they were the most alone any human beings have ever been. They photographed the EarthSat. They photographed the eclipse. They photographed the South Pole Aitken Basin, one of the largest and oldest impact structures in the entire solar system, in the sharpest resolution ever achieved by human observers. They photographed the Orientale Basin and suggested 2 smaller craters within it be named Integrity and Carroll. 31 cameras captured thousands of images that will fill textbooks for generations. But the discovery that will change how NASA plans every future mission to the moon, the cameras missed. And that discovery connects to something that has haunted lunar science for centuries. For as long as human beings have pointed telescopes at the moon, astronomers have reported mysterious flashes, glows, and color changes on the lunar surface. These reports are called transient lunar phenomena, or TLP, and they stretch back hundreds of years. Some of the earliest documented observations come from the 18th century, when astronomers using modest refracting telescopes reported bright points of light appearing and vanishing in seconds on the lunar disk, reddish glows in craters that seemed to have no source. Brief luminous events in areas that should have been dark and inert. In 1787, the astronomer William Herschel reported seeing what he described as bright spots on the dark side of the moon during a lunar eclipse, which he attributed to volcanic activity. In 1958, the Soviet astronomer Nikolai Kozyrev observed a reddish glow in the central peak of the crater Alphonsus and obtained a spectrogram that he interpreted as evidence of gas emission. NASA itself compiled a catalog of over 570 TLP reports spanning 4 centuries, published in 1968 as NASA Technical Report R277. The phenomena were real in the sense that credible observers kept reporting them. But for most of the history of astronomy, these reports were dismissed, marginalized, or explained away. Atmospheric distortion, observer bias, overactive imagination, wishful thinking. The moon was supposed to be dead, geologically inert, a cold, airless, tectonically frozen body, where nothing interesting had happened for billions of years. Nothing should be happening on its surface that would produce visible light. But some observers were harder to dismiss than others. Apollo 17 astronaut Harrison Schmitt, a trained geologist with a doctorate from Harvard, the only professional scientist to ever walk on the lunar surface, reported seeing mysterious flashes during lunar night in December 1972. Schmitt was not a casual observer making an offhand remark. He was one of the most qualified scientific observers in the history of the space program, trained specifically to make precise geological observations under field conditions. And he understood the difference between an instrument artifact and a physical event. He saw flashes on the lunar surface. He reported them clearly and precisely to mission control, but nobody could independently confirm what he saw. The cameras of 1972 were film-based systems that required exposure times measured in fractions of a second at minimum, not the thousandths of a second needed to capture a meteoroid impact flash. The photographic technology simply could not record what the human eye could detect. There was no way to independently verify a millisecond flash on an unlit lunar surface using 1970s equipment. There was no second data source, no corroboration. And there was an alternative explanation available: cosmic ray interactions with the astronaut's retina, a known phenomenon that Apollo crews reported separately as light flashes, visible with their eyes closed inside the spacecraft. Schmidt's observation could be explained away, and for most of the scientific community it was. For 54 years, his report sat in the Apollo archives, unconfirmed, unexplained. A single data point from a single observer, filed alongside centuries of transient lunar phenomena reports that the scientific mainstream had never fully embraced. On April 6, 2026, the Artemis II crew confirmed it. 4 observers instead of 1. 6 documented impacts instead of a single unverified report. Detailed verbal descriptions cross-referenced with 24 scientists listening in real time at Johnson Space Center. What Schmitt saw in 1972 was real. What centuries of ground-based astronomers reported from Earth was real. The moon is being bombarded continuously by meteoroids, and the impacts produce flashes visible to the human eye from thousands of miles away. The far side has been enduring this bombardment for 4.5 billion years without a single witness, until now. And the paradox at the center of this confirmation is worth sitting with. The oldest mystery in observational lunar astronomy was not solved by a new telescope. It was not solved by a new satellite, or a new algorithm, or a new imaging technique. It was solved by 4 people looking out a window, the same way Schmitt saw it, the same way astronomers, centuries ago, saw it. Human eyes, pointed at the moon, watching. But this is not just about confirming what Apollo crews saw half a century ago, because what the Artemis II data reveals about the rate and energy of far-side impacts has immediate, practical, and sobering implications for what comes next. NASA is planning to build a permanent human presence near the moon's south pole, the Artemis Base Camp. Habitats designed for extended stays, power systems, communication infrastructure, scientific equipment, rovers, landing pads. Human beings living and working on the lunar surface for weeks and eventually months at a time. Everything about that plan assumes a certain level of understanding about the lunar environment. And one of the most fundamental questions about that environment is how often things hit the surface, how hard they hit, and how much damage they do. Think of it like this. You are planning to build a house in a field. You have studied the field from a distance for decades. You have photographed it from orbit in extraordinary resolution. You have sent robots to sample the soil and measure the terrain and test the bearing capacity of the ground. Everything looks safe, manageable, well understood. And then for the first time, you stand in the field at night and watch rocks fall from the sky and explode on impact around you. The field is the same field. The data is the same data. But your understanding of the risk of living there has just fundamentally changed. You did not know rocks fell here at night because you had never stood here at night. The impact flash observations from Artemis II are now being incorporated directly into hazard models for the Artemis Base Camp. How often do impacts occur at various size ranges? What is the size distribution of the meteoroids responsible? What kinetic energies are involved at each size threshold? What does that mean for habitat wall thickness and shielding mass? How should EVA schedules be structured to minimize crew exposure during periods of elevated meteoroid activity? How close to a predicted impact zone should critical equipment be placed? These questions had theoretical answers before April 6, derived from orbital observations of the near side and statistical models extrapolated to the far side. Now they have direct observational data collected by human observers at close range on the far side itself, data that can be compared against the models and used to calibrate them for the first time. So here is where the story arrives at the present moment. The Artemis lunar landing is now targeted for early 2028. The impact flash data from Artemis II will directly inform where that landing happens, how the habitat is designed, and how astronauts schedule their work on the surface. Future missions will carry instruments specifically designed to detect and characterize impact flashes, cameras with wider fields of view, higher frame rates, optimized for catching millisecond events at random positions. The technology will catch up. It always does. But the lesson of Artemis II is that technology alone is not sufficient. 31 cameras aboard the most advanced spacecraft humanity has ever sent to the moon. The most important discovery of the mission was made by 4 people looking out a window, and the cameras missed it. NASA continues to analyze the thousands of images, the crew's detailed observation logs, and the scientific data gathered during the 10-day mission. The Oriental Basin photographs are being studied for geological context. The eclipse corona data is already published and generating scientific papers. The mission lasted 10 days from launch to splashdown. The analysis will take years, perhaps decades. But I want to end on something that stays with you, because this story is not about impact flashes. In 1968, Apollo 8 astronaut Bill Anders photographed Earth rising over the lunar horizon. It was the first time any human being had seen their home planet from another world. That photograph, Earthrise, changed how humanity saw itself. A small blue marble hanging in infinite blackness, fragile and alone, carrying every person, every species, every civilization that has ever existed. The photograph did not discover anything new about Earth. It showed us what we already knew, but from a perspective that made us feel it for the first time. In 2026, the Artemis II crew photographed Earth setting behind the far side of the moon, Earthset. The same perspective, reversed. The same revelation, deepened. Earthrise, in 1968, said, "Look where we came from." Earthset, in 2026, says, "Look how far we have come. And look what we nearly stopped doing." 54 years between Earthrise and Earthset. 54 years of not going back. 54 years of sending robots and probes and orbiters instead of people. And in all that time, nobody saw the flashes on the far side, because nobody was there to look. We sent 4 people to the moon, not robots, not probes, not autonomous cameras or AI systems or machine learning algorithms. 4 people in a capsule the size of an SUV, 250,000 miles from everyone they have ever known. And the most important thing they brought back was not a photograph, although the photographs are extraordinary. It was not data, although the data will reshape lunar science. It was not a measurement or a reading or a spectral analysis. It was a story about what they saw with their own eyes, that no camera could record. A story about flashes of light on the far side of the moon, violent and brief and beautiful, that have been happening for 4.5 billion years without a single living creature to witness them. For 54 years, nobody went to the moon. 54 years of robotic probes and orbital cameras and remote sensing and algorithmic image processing. And in all that time, with all that technology, nobody saw the flashes. Because technology sees what it is pointed at. Human beings see what is happening. We build cameras that see further than our eyes, telescopes that see deeper, sensors that detect what we cannot feel, and instruments that measure what we cannot touch. And still, on April 6, 2026, the most significant observation from the first crewed lunar mission in half a century was made by a human being glancing out a window at the right moment and saying, "I see something." That is why we go. Not because robots cannot do the work, but because some things can only be seen by someone who is there. And some things are only worth seeing because someone is there to be changed by what they see. 4 people, 40 minutes of silence, 250,000 miles from everyone they love, and flashes of light on a surface nobody had ever watched. That is Artemis. That is why we stopped sending only machines. That is why we go back. If this kind of story is what you come here for, subscribe right now and turn on notifications, because next time we are covering what the Artemis II eclipse data is revealing about the sun's corona from a perspective no human has ever had before. And the analysis is producing results nobody anticipated, starting with the corona. Drop a comment with what hit you hardest. The 40 minutes of silence behind the moon, the flashes the cameras missed, or the Earthset, the moment our planet disappeared below the horizon and 4 human beings were more alone than anyone has ever been. And share this with someone who thinks space exploration can be done entirely by robots. Because on April 6, 2026, behind the moon, cut off from the rest of humanity, 4 pairs of human eyes proved them wrong.